All right, we're going to begin with review exercise number 99. Practice exercise number 99 today. A little bit of algebra review. You're welcome to use a calculator. Not sure how much the calculator will be of benefit to you necessarily, but you're welcome to use it. You've got 6 equations to solve for x. However, x is going to be an integer, which means if you get an answer that's a fraction, that ain't the one we want. So in the case of if you were to get, for instance, a couple of answers, we're going to get an integer answer for exercise 99. All right, you may begin. For sake of time, let's go ahead and take a look at the answers to these together. And Quentin was first. Quentin, what did you get for your first answer?
8.
X equals 8. Very good. How about for the second one?
8.
X equals 8 again. And for the third one?
5.
X equals 5. So again, your answers to the top row are 8, 8, and 5. For the bottom row, we had some inequalities. And what did you get for your first inequality?
7x plus x is greater than 5 halves.
Huh?
7 halves is less than x is greater than 5 halves.
Yeah, I think you made this really hard. Oh, correction. You said that x had to be in between 5 halves and 7 halves, right?
Yeah.
Okay. In other words, 2.5 and 3.5, right? What integer is between 2.5 and 3.5? 3. That's your answer, since it had to be an integer. X should have just been 3 for that one. Chris, are you good on the top row? Did you get 3 for the integer value on that first one? You did not. Does it make sense now? Mm-hmm. So looking at the next one here, what integer should we have gotten for that second one on the row, Chris?
10.
Should have been 10. What can you divide by 5 to get a result? Oh, wait. Well, x over 5 should be 10, so x should be... Sorry, I was looking at the wrong part. I wasn't looking at the answer. I was looking at a little notation I'd made.
50?
Should have been 50. What could you divide by 5 to get an answer between 11 and 9? It would be 50. Should have been in between those values. What about that last one? What value of x would give me a value that lies between 11 and 15? Quentin, back to you. 1 should have been our answer there. So doesn't seem like we actually quite got it, but we understand now, gentlemen. Let me address the rest of the class then. Let's go top row, because top row was straightforward. Did we all get 8, 8, and 5 for the top row? Are there any questions on the top row? You need to see one worked. All right, so again, how do we think through this? 10, now they've got this written backwards notation, which I don't care for. 10 is greater than 2x plus 3 is greater than 8. But basically you see that that right there has got to be a 9, right? What is between 10 and 8? 9. So in that case, if 2x plus 3 has to equal a 9, what's x going to be? 3. Does it make sense? Looking at the next one, we've got 11 is greater than something divided by 5 is greater than 9. What is between 11 and 9, class? 10. Okay, so that means the x over 5 has to be equal to a 10. So what's x? 50. And then the last one, 15 is greater than or equal to 5x plus 6 is greater than or equal to 11. Well, here there's a few possibilities. What is between 11 and 15, class?
14, 13, 12. 11.
And because of the or equal to, 15, 14, 13, 12, or 11, any of these could work here, right? So if we were to subtract 6 from any one of these, which of them could be evenly, again, it has to be an integer, divided by the 5? Well, if you subtracted 6's from all of these, that would give you 9, 8, 7, 6, 5. Which of those could be divided evenly by 5?
The 5.
Only the 5. And 5 divided by 5 is 1. In other words, you can plug in a 1 right here and get 11, which fits. But if you try to plug in a 2, you get a 16, which doesn't fit. Does that make sense? Questions on this exercise?
Wasn't this algebra 2?
This is more intuition and logic, understanding and thinking. This isn't necessarily a process you're per se taught. Because again, as soon as I show it to you, you're like, oh, that's what we do. It's just an intuition thing.
I remember learning this in summer school, that's what I asked.
Well, we've learned inequalities in Algebra 1 and Algebra 2. We didn't necessarily approach them quite this same method because we were able to get other things.
Correct.
The thing that makes this different is they're saying x is going to be an integer. And that's the kind of thing standardized testing, ACT, SAT testing will do to test your intuition, rule out the basic process of how to solve. Find the shortcut, knowing it's got to be an integer. So there we go on that. Any questions? All right. But it doesn't sound like anyone got the candy today. So we'll hold that for the next exercise. Go ahead and pass those in if you would, please. And take your homework handouts out. Homework handouts out. talked yesterday about the number of square units that will be contained within a geometric plane figure. And we're talking, of course, Jamie, about
area.
Area is that number of square units contained within a geometric plane figure. And in fact, we said this, that if two figures have the same area, we would consider those figures, Genesis, to be equal to each other. So do two figures have to be similar to be equal, class? No. Always, sometimes, never, similar figures are equal. Sometimes, could be always, sometimes, never, equal figures are similar. Sometimes, always, sometimes, never, equal figures are congruent. Sometimes. Always, sometimes, never, congruent figures are equal.
All the time.
Always, yes. Congruent figures have to be equal. Equal figures don't have to be congruent. In fact, they don't even have to be similar to each other. We have several area formulas that you need to know that you were using last night. The most basic area formula is that of a rectangle. What is our formula for the area of a rectangle, Ethan?
R, capital R, equals BH.
Good. Capital R equals BH. What about our basic formula for the area of a square, Quentin? Well, I use SQ just to make sure it's clear. Because S sometimes could be side or something like that. So anyway, SQ just to differentiate. There we go. We also had a parallelogram, Kendall. There we go. We also talked about the ability to compare the areas of a couple of rectangles to each other. Audrey? There we go. Or we could do something very similar with a couple of parallelograms. Chris?
Parallelogram. PL is to PL, what's it called?
Class?
Prime.
Prime.
Yeah, that's it. As BH is to BH, or B prime is prime.
There we go. And so we said in the case of both rectangles or parallelograms, class, if they happen to have equal bases, then their areas will be to each other as their altitudes. And if they have equal altitudes, then they will be to each other as their bases. And of course, if they have equal bases and equal altitudes, then they must be
Equal.
rectangles. That's a good point, because I kind of got you mixed up there, Ethan. Rectangles with equal bases and equal altitudes, class, are congruent and equal by default. Parallelograms with equal bases and equal altitudes are equal, but not necessarily congruent, right? Now, if there are similar and equal, of course, they would be congruent. But remember we said parallelograms, you could have this base here and this altitude here, or you could have that same base here and this same altitude here. And these, if they have the same base and same altitude, would be equal areas, but they are not necessarily going to be congruent, obviously, right? Questions on all of this? Well, let's take a look at the handout then, and go and read that first problem for us, if you would, Kendall.
Find the area of a rectangle that has a base of 15 feet and an altitude of 3 meters.
All right, and we write the formula first. That's always a good thing to do, Kendall.
R equals BH.
All right, and then what'd you plug in where?
For the base, it's 15 feet, and for the altitude, it's 2 yards.
All right, thoughts, Kendall?
You have to convert yards into feet.
Or
Feet into yards.
one of these has got to change. So either we change the 2 yards into,
6 feet.
and then we would multiply to get what area, anyone? 90 feet squared. You might have had that answer. Or, Kendall, we could turn 15 feet into, how many feet in a yard?
5.
The answer is 5. Yeah, 3 feet in a yard. 5 yards is the answer there. So in that case, we could also say the area, class, would be 10 yards squared. Either answer is acceptable. How many had the 10 yards squared? Okay, so how many had either answer? You had one of them. All right, questions on this. Did anyone have 30 feet yards? Yeah, you can't do that. That's why we got to
30
change
yards.
it. That's what it would be.
Oh.
Just multiplies 30 feet yards. And that makes no sense, which is why you have to change the units to make
I almost fell for that.
match. All right, let's take a look at the second problem. Go ahead and read that for us if you would, Genesis.
The area of a rectangle is 27.14 inches. The altitude is 4.6 inches. What is the base?
All right, and again, we'll start with the area formula.
R equals
And how do we plug things in here?
you do R equals 27.14.
Right, in place of the R, we're going to plug in 27.1 for those inches squared. Yeah, inches squared. All right.
Equals 4.6. Well, B times 4.6.
There we go. The B times the 4.6. We're to solve for the B, I would need to.
Move the 4.6 over as a negative.
Well, if it were being added, yes. But it's not being added, it's being multiplied.
Divide away the B.
Right, divide away the 4.6 inches. And what should we have gotten for number 2?
5.9.
5.9. Well, area is square inches. It's just a base. So it's just 5.9 inches is a plain old measurement. How many are the 5.9 inches for number 2? Any questions on that? Number 3, go and read that one for us if you would, Audrey.
One rectangle has a base of 3 feet and an altitude of 6 feet. Another rectangle has a base of 4 feet and an altitude of 9 feet. Find the ratio of the two rectangles.
Now, since there's 2 rectangles, Audrey, once again, we're going to want to use that proportion you gave us a moment ago.
R is R prime as B equals 2 times H prime.
And I'm not solving for R or R prime. I'm solving for this entire ratio because it says find the ratio of the 2 rectangles. Audrey, what should we do?
And plug in the numbers.
Plug in the numbers. So in place of the B
3 feet and 6 feet.
for the H, all right?
And then for the bottom, it would be 4 feet and 9 feet.
All right? And what's going to happen to all the feet? They're all going to cancel because remember, a ratio doesn't have units. We could just multiply and get,
I don't know, because
you went ahead and canceled stuff. If we didn't, though, you're smart enough to do this in your head. What would we get if we just multiplied? 18 to 36, which could reduce down to 1 to 2, right? So you would get that ratio 1 to 2, or you could do what Audrey did, which she did some canceling. Okay, or you could cancel the 3 with the 3 to get 2 over 4, or then cancel the 2 with the 4 to get 1 over 2. And so all kinds of canceling you could do. But as long as you ended up with a 1 to 2 ratio, how many had that ratio? What that means is the second rectangle is literally twice as big as the first, 1 to 2.
I just did reduce. I had 18 over
You had 18 to 36 as your answer. Okay. Questions on number 3. Number 4. Go and read that for us, Quentin.
Find the area of the square of the size 3.4 centimeters long.
And what equation do we need to use again here?
SQ equals S squared.
There we go. And we're given the sides 3.4 centimeters, so to find the area, we just plug it in and square it to get 11.56 centimeters squared. How many have that answer for number 4? All right, number 5. Read that for us, Jamie.
Find the length of each side of a square that has an area of A1 inches squared.
Once again, what formula do we need?
The SQ equals S squared.
But this time, we're going to take the number they give us, that 81 inches squared, and that's getting plugged in for the SQ. So to find the length of a side, what are we going to need to do?
Take the square root.
Take the square root. And when we take the square root, what do we get, Jamie?
9 inches.
Equals S. How many had a side of 9 inches on this one? Questions on that one? Let's go to number 6. Read that for us if you would, Ethan.
Find the length of a diagonal of a square that has an area of 169 meters squared.
All right, so we're given the area of a square, so we should probably use the formula for the area of a square.
SQ equals S squared.
We're once again, like last time, we're given the area, so the 169 meters squared goes in for the,
13? Wait, what?
where do I plug in the 169 meters squared?
Into S squared.
Class, the S cubed, that's the area. So I plug that in for the area. And then I need to find the S by taking the
13 squared.
square root. You're jumping way ahead of me, Ethan. You're trying to give me the answer. I'm not ready for the answer yet. I'm working through so we can explain what we did. The area goes in for the area. And to find S, since it's being squared, I take the square root. Now, Ethan, when we take the square root of 169 meters squared, what do we get for the side?
13.
13 meters. That's the side. But this is 11th grade. I didn't ask for the side this time. I asked for the diagonal. Well, I don't have a formula that has the diagonal in it, do I? But if I were to, say, draw a picture of a square, and I were to go ahead and label what I did find, that each side is 13 meters, then perhaps I could find the length of a diagonal. And what would the length of the diagonal be?
I got it wrong. I thought it was 36 or 90. It's 45, 45.
It is a 45, 45, 90. So what should we have gotten?
6?
Oh, the
No,
pain.
13 times 46.
13 times the square root
How
of
far
2
is it?
meters should have been our answer there. Again, we draw that diagonal, either Pythagorean theorem, you've got your two legs, you just need the hypotenuse, or better yet, the 45, 45, 90. How many had? 13 times the square root of 2 meters. Do you see how we're doing a concept that we talked about earlier and tying it in now with area, tying the two together? Questions on that? That's more 11th grade level. Let's go to number 7, and go and read that one for us if you would, Genesis.
Find the area of a parallelogram that has a base of 14 centimeters and an altitude of 6 centimeters.
And for this, we need what formula?
PL equals B times H.
All right, and what do I plug in where?
PL equals 14 centimeters times 6 centimeters.
There we go, plugging the 14 centimeters for B, plugging the 6 centimeters for H, and so you're just multiplying. And what do you get?
84 centimeters.
PL equals 84 centimeters squared. Excellent. How many had the same answer for number 7? All right, number 8. Kendall, read it for us.
The area of a parallelogram is 57 feet squared, and the base of a parallelogram is 6 feet. Find the altitude.
I should say the base of the parallelogram is 6 feet. Otherwise, it's like, well, we got this one parallelogram with an area of 57, and we got this base of some other parallelogram with 6 feet. What altitude are we talking about now? So, pardon the grammar there. What formula do we need to start with?
PL equals B.
Yeah, this time though, what do we plug in where?
57 feet squared for the PL. And the base is 6 feet.
And of course, then we're finding the altitude. So we need to simply divide away the 6 feet to get.
9.5 feet.
Good, 9.5 feet, I'll take it since it's an ending decimal, or 9.5 feet would work as well. How many had 9.5 feet or 9.5 feet? Questions on that? All right, let's take a look at the extra credit now, if you would. You can set the handout aside, or maybe use the back side of the handout. That would be fine as well. Let's turn to page 240. Page 240. And exercise number 9 was extra credit. How many did the extra credit? You attempted the extra credit.
I got stuck.
You tried it and got stuck. Anyone else attempted?
I tried and got stuck.
Tried and got stuck? All right, well, let's go and try it now then. And let's see here. Ethan, would you go ahead and read number 9 for us, sir?
Two adjacent sides of a parallelogram are in the ratio of 5, and the equated angle is 60 degrees. If the area of the parallelogram is 1,280 times square root of 3 square feet, find the sides.
Probably what we need to do here, Ethan, is draw a picture, right? There's a whole lot going on here. So let's go and draw a parallelogram. And let's label some things on the parallelogram. You said that the, what was the first information they gave us?
adjacent sides of the parallelogram are in the ratio 4:5.
Adjacent sides are in ratio 4 to 5. Now class, adjacent sides are not base and altitude. Do we all understand that? In a rectangle, the adjacent sides are the base and altitude. In a parallelogram, one of them's the base, the other one's just another side. And furthermore, it says they're in ratio 4 to 5, Ethan, so I don't even know how long the sides are. But I could represent them 4x and 5x. Did we at least get that much of a start, gentlemen, as you tried it? The rest of you would understand what these gentlemen did at first. All right, what's the next piece of information that they give us, Ethan?
An included angle of 60 degrees.
There's an included angle of 60 degrees. Now, class, as soon as you see that information, 60 degrees, your brain should be thinking 30, 60, 90. Problem is, I ain't got a 30, 60, 90. But I can make one by drawing,
A diagonal.
not a diagonal.
Auxiliary line.
I do want an auxiliary line, but what auxiliary line, Chris? Because
Short.
diagonal here wouldn't give me a 30, 60, 90. This way? I mean, that would give me a 30. Well, it wouldn't necessarily even give me 30s, but somebody help? A perpendicular. Specifically, the perpendicular from the top vertex. Now I have a 30, 60, 90. Do we see it?
And that's where I'm
And by the way, what do we call this perpendicular, class?
the altitude.
Now, technically, the altitude could be drawn anywhere, but in order to generate a 30, 60, 90, it needed to come from this first vertex. So, Ethan, if we're calling this line 4x, normally this line would be labeled
2x.
2x. Normally, this little piece right here would be labeled x. So normally this is 2x and this is plain old x, right? You cut this line in half. But this line is actually 4x. So how big is that piece?
2x.
2x. Normally, Ethan, this line would be called,
X times square root of 3.
it would be this length, x, times the square root of 3. But this time this length is 2x. So I could label this line,
2 times square root of 3x.
well, 2x times
2x.
the square root of 3.
Yeah, that's what I meant.
Do we all understand how to represent this? And this is your base, and this is your altitude. And there's one more piece of information here, Chris.
The area is 1,280 times the square root of 3.
The area, the PL, is 1,280 times the square root of 3
Square feet.
square feet. And I know my base class is represented 5x. And I know my altitude is represented class 2x times the square root of 3. At your seats, solve. What do we get when we multiply these two values together? 5x times 2x times the square root of 3. Anyone?
10x times square root of 3.
Close.
10x squared.
10x squared times the
I forgot
square root
that.
of 3. That's going to equal 1,280 times the square root of 3 feet squared. What should we do next? Someone besides Chris?
Divide by 10. 10x first. 10x.
I want to get the x squared by itself, right?
The square root of 3.
Divide away the 10 times the square root of 3. I want to divide away the 10 and the square root of 3. Make sense? And that's really nice because there goes the square root of 3, there goes the 10, and now I get x squared is equal to 128 feet squared. Last thing I would need to do, someone besides Chris and Quentin.
Square x.
Ooh, no. Not square the x. take the square root. There we go. Let's take the square root of both sides. I think that's what you meant. Not square, square root, opposite operation there, right? And let's see. That doesn't come out evenly, but I can reduce this. Factor the 128, 64 and 2 to get
8 whole squared. Yeah.
and then also take the square root of feet squared, feet. And that's my x. Now, that's not what they asked. They didn't say solve for x. They said find the sides. Well, one side is 4x. So if x is 8 times the square root of 2 feet, class, 32 times the square root of 2 feet. And if the other side is 5x,
40 times the square root of 2 feet.
and there we go. Questions on this? This is 11th grade. It's not junior high, right? Anybody can, given the base and altitude, multiply to get the parallelogram. Okay, great. I want to know, can you go a little bit deeper? Can you get ratio values? Can you work with a 30, 60, 90? Can you do a little bit of algebra, reducing radicals and such? Questions on it now that we've seen it worked. We'll get more practice with problems like this in just a little bit. For now, if you would, theorems, corollaries, section of your notebook. For now, theorems, corollaries, section of your notebook. Yesterday, we had rectangles, squares, parallelograms. Let's add another figure to our lineup here as we continue working through areas of different figures. Theorem 70. Theorem 70, should have copied Theorem 69 in the corollaries last night. Theorem 70, picking up where we left off, says this: the area of a triangle, is equal to 1/2 the product of its base and altitude. The area of a triangle is equal to 1/2 the product of its base and altitude. The area of a triangle is equal to 1/2 the product of its base and altitude. Consider any triangle for just a moment. We want to prove that the area, if you would write this by the way at the end of the theorem, that the area of the triangle T is equal to 1/2 the product of its base and its altitude. Let's consider for just a moment, here's the altitude of the triangle, here's the base of the triangle. Well, consider what we already know. We already know that a rectangle is base times altitude, and we know that a parallelogram is base times altitude. So to show that a triangle is 1/2 of base times altitude, perhaps we could show that a triangle is 1/2 of a parallelogram or rectangle with the same base and altitude. I'm going to take that line of thought. You know that from a point or through a point, one and only one straight line may be drawn parallel to a given line. So from this point, I can make the only parallel that can be drawn to this line. Similarly, from a point, one and only one straight line may be drawn parallel to a given line, so I can draw the parallel here. We furthermore know that two straight lines can intersect at one and only one point. So this point is predetermined if you draw parallels. Well, what I now have is a four-sided figure, don't I? The altitude is the same as it always was, same as the triangle. The base is the same as the triangle. But if opposite sides are parallel, I now have a parallelogram. The area of the parallelogram we already proved was base times altitude. However, if this side equals this side, and this side equals this side, and if these lines are parallel to these lines, right side to right side, left side to left side, the angles are equal. Also, opposite angles of a parallelogram are equal. Then by side angle side, this triangle is congruent to the first. And if congruent, then equal, same size and shape. Which means the parallelogram, which equals base times altitude, also equals exactly two triangles of this size. Well, if two triangles equals parallelogram, then triangle equals 1/2 a parallelogram, or 1/2 base times altitude. Make sense? So yes, we've proven that a triangle equals half the product of its base and altitude. Corollary 70-1. Corollary 70-1. Any two triangles are to each other. Any two triangles are to each other as the products of their bases and altitudes. Any two triangles are to each other as the products of their bases and altitudes. Once you have that down, write this down. T is to T prime as BH is to B prime H prime. Any two triangles are to each other as the products of their bases and altitudes. That is, that T is to T prime as BH is to B prime H prime. Now wait a second. I understand that being good for rectangles because R is BH. R is BH, or PL is BH, but T is not BH. T is a half BH. Shouldn't it be T is to T prime as a half BH is to a half B prime H prime? Thoughts? The halves cancel, don't they? Yeah, that's why we don't need to keep the halves. And so therefore, just like rectangles and parallelograms are to each other as products of bases and altitudes, so are triangles. Which means, corollary 70-2, corollary 70-2, which means that two triangles having equal bases are to each other as their altitudes. This sounds kind of like a broken record. Two triangles having equal bases are to each other as their altitudes. Two triangles having equal bases are to each other as their altitudes. Corollary 70-3, two triangles having equal altitudes are to each other as their bases. You saw that coming, didn't you? Corollary 70-3, two triangles having equal bases are to each other, or altitudes are to each other as their bases. Whichever one I didn't just say. Forgot which order I went in.
Bases and then altitudes.
Yeah, 70-2 is if they have equal bases, they are to each other as their altitudes. So corollary 70-3, having equal altitudes are to each other as their bases. And you may even be able to guess corollary 70-4. Yes, sir.
In my book, corollary
Do I go by the book?
No.
Did I? No. All right, corollary 70-4, two triangles having equal bases and equal altitudes are equal. Two triangles having equal bases and equal altitudes are equal. Now again, that is more profound than you might initially think. Because that means those triangles having equal altitudes and equal bases would be equal. They're not similar, but they are equal. Make sense? You could have an obtuse triangle and an acute triangle. For that matter, we could make a right triangle with that same length as base and that same altitude, and that triangle would be equal to the others as well. If they have the same bases, same altitudes, they have to be equal, even though they are not similar. Make sense? And your book includes another corollary. We skip it because it was used to do the proof. So again, we don't go by the book. All right, turning your books to page 240 now. And let's look at exercise number 1. Let's practice a little bit with this triangle formula. T equals a half BH. T equals a half BH. Go and read exercise number 1, if you would please. There in your textbook. Chris.
Find the area of a triangle whose base is 15 inches and whose altitude is 6 inches.
All right, and let's start with the formula, class.
T equals 1/2 BH.
And it says to find the area, so I'm finding T equals a half times in for the B I plug in.
15 and 6.
15 inches in for the H I plug in.
6 inches.
6 inches. Now, strategy tip, class. I don't like to dig out the calculator because I'm lazy. It would be easier, rather than trying to do 5 times 6, 15 times 6, which I don't know, and then try to divide that by 2, which I don't know. Wouldn't it be easier to just knock off the 2 with the 6 to get a 1 and 3? And now I'm doing 15 times 3, which because I can read a clock, I do know, is 45, and of course inches times inches squared. Anytime you can knock the 2 out with one of these numbers, do so. Just makes your life a little bit easier. Again, not wrong to multiply to get, 90 and then take half of 90 to get 45, if you wanted to do it that way. Also on the calculator, instead of saying times 0.5, dividing by 2 is a lot easier to do typically. So just another strategy tip there. It's one less keystroke, and I am that lazy. All right, questions on this? Divide by 2 to take your half. How about number 2? Jamie, read it for us.
The area of the triangle is 176.66 square feet. The base is 24.2 feet. Find the altitude.
Once again, it's a triangle, so I want to start with the formula class. T equals a half BH. But this time I'm not finding T, I'm told T. So what do I plug in place of the T, Jamie?
176.66.
What unit was it?
Square feet.
Feet squared, okay? And it equals a half times, did they give me the B or the H?
The B.
They gave us the B to be
24.2 feet.
24.2 feet, and I'm finding the H. Now, once again, do you see I can easily take half of one of these numbers? Now, H isn't a number, so it's only the B that I've got. Do not, by the way, reach across the equal sign and cut this in half. You can take half of 24.2, class, to get 12.1. Like you're literally just cutting every digit in half. And now to get the H by itself, away the 12.1 feet, technically. And that'll give us 14.6. Someone else got the same thing? 14.6. And notice the feet squared divided by feet just gives us feet. Now, what if, though, this had been, say, a 15.7? Can you cut that in half? Not easily. What would be an alternative? Let's just say, and I don't know how these numbers are going to work out, but let's say we had 166 feet squared, and the base was 15.7 feet. And I'm like, ooh, I don't want to try to take half of that, because, lazy, remember? What would be an alternative? Get rid of the fraction altogether. Going back to your algebra days, how do I get rid of a fraction? Multiply everything by the LCD, which is, by the way, the reciprocal of a half. Just multiply both sides by 2. The 2 and the half will cancel, so I'm left with a 15.7H. And then on your calculators, 2 times 176.66?
143.
Multiply it on the calculator. There's too much carrying involved.
143 something.
353.32.
Did I say 1? Did I say 1?
All right. And then we just need to away the 15.7. So again, if you can cut a number in half and get rid of the half that way, to me that's easier because you can do it in your head. And doing stuff in your head is always easier. If you don't have that option, multiply both sides by 2. That'll knock out your half. Again, not dividing over here by 2, multiplying by 2, and you can divide away the other number, and I'm sure it doesn't come evenly, or does it?
No.
I'm pretty sure it didn't, okay? Give me just the first few digits. 22.50 ... feet would be our altitude then. But I wanted a chance to show that with the 1/2. 2 ways to handle it. Either get rid of it, multiply both sides by 2, or go ahead and just use the half to cut one, or in this case I had 2 numbers to pick from here, and I only had the one choice, but cut a number in half that's on the same side. Questions on how to work with the half? All right, take a look at number 8 now, and read that for us if you would, Genesis.
The ratio between the base and the altitude of a triangle is 2 to 3. If the area of the triangle is 180 square inches, find the base and the altitude.
All right, now, here they don't give us the base or the altitude, but they tell me what about the base and altitude?
To find them.
Well, to find them, but they tell me some information about them that helps me find them.
2 to 3.
They're in ratio 2 to 3. So if we start with our formula, Genesis,
T equals 1/2 BH.
I can represent the B as
2.
class 2x, and I can represent the altitude, the h, as 3x. In ratio 2 to 3, so 2x and 3x, of course, don't lose your 1/2. And they give me the area, so then for the t I can plug in
180 square inches.
108 square inches. You're Liz Dexic too. All right. 108 inches squared. Hey, we're in this together. All right. Thoughts on what I might do to simplify some things here, Genesis? I could also just cancel these 2's with each other, or I could multiply by a separate 2 on both sides. And that's not wrong, especially if you just say, you know what, I just want one method that always works. You know what? That does always work. Just multiply both sides by 2 every single time. You don't have to think about it. I like to find easy ways, but this way does simplify your life, I suppose. Here, Genesis, we get
216.
And now all we're left with is the 2x times 3x.
6x squared.
6x squared, there we go. From here,
Divide away the 6.
and that'll get us x squared is equal to, anybody, 36 inches squared. And then take the square root of both sides and get 6 inches. Because when you take the square root of inches squared, it comes out to plain old inches. So the base, remember, was 2x, the altitude was 3x. X is 6 inches. What are the base and altitude, Genesis? 12 inches for the base, good, and 18 inches for the altitude. Questions on number 8? Questions on that? Getting a feel for how to work this. And again, this is just a step up from what you did in junior high, dealing with ratio quantities. Let me give you a couple more of these. Suppose we have a triangle here, and I know that the area is 45 feet squared, and I know that the base is 15 feet. At your seats, find the altitude. And how many finished with the first one? Several people. What did we have for our answer, class? 6 feet. 6 feet. How many had 6 feet for your altitude? Again, plug it into the formula. G equals a half BH. You got your 45 as your T. A half times 15 times H. Multiply both sides by the 2 to get rid of the half. To get 90 equals 15H, and then H is 6. Questions on that first one? The next one, I've got a triangle with adjacent sides of 10 inches and 24 inches, and I've got a 45-degree angle between them. Find the area of the triangle. Hopefully you recognize that to find the area, you need to have base times altitude. Well, I know the base, class, 24 inches. That was clearly spelled out. But the altitude wasn't even in the picture. Hopefully you drew an altitude, but when you did, class, you formed a, specifically a 45, 45, 90. Where normally we would label, stay with me, these two segments as X, and normally we would label this side X times the square root of 2. So if 10 is the x square root of 2, what did you find the x's to be? Five times the square root of 2, which means since the altitude was one of the x's, the altitude is 5 times the square root of 2 inches. Now we can solve. Let's cut the 24 in half, class. And now we just multiply to get 60 times the square root of 2 inches. This is extra credit for you this evening. Copy it down. We've got a parallelogram with adjacent sides of 8 centimeters and 10 centimeters. We have a 60-degree included angle. Find the area of the parallelogram. We'll take a look at that tomorrow, as well as reviewing some other things in our lesson tomorrow. Have a wonderful rest of your day.